We've considered most of the elementary transformations. Let's take care of the last bits. What's going on when the graph of sine or cosine is compressed or stretched horizontally? If you have internet, click on the hyperlink below for a Desmos simulation. There are two graphs. One is f of x equals sine x and the other is g of x equals sine of bx for changing values of b between 0 and 5. Let's consider the cosine function and a set of numbers inside the parentheses as shown below. Describe a set of inputs that produces a complete cycle. Discuss. If you replace the question mark with x, then f of x equals cosine x. We know that a cycle is achieved for any 2 pi interval including x that is greater than or equal to 0 and less than or equal to 2 pi. What happens if the inner function is bx? F of x equals cosine bx. Therefore, bx is greater than or equal to 0 but less than or equal to 2 pi. And if we divide each piece here by b, we get that x is greater than or equal to 0 and less than or equal to 2 pi over b for a complete cycle. Stretching the graph of sine x horizontally away from the y-axis is given by g of x equals sine of bx, provided that b is between 0 and 1. Bx is greater than or equal to 0 and less than or equal to 2 pi implies that x is greater than or equal to 0 and less than or equal to 2 pi over b for one cycle. Consider f of x equals sine x here in red, and its transformation g of x equals sine of 0.5x. So since the b value is between 0 and 1, we take each point and move them away from the y-axis. The new period of this function is x that is greater than or equal to 0 but less than or equal to 4 pi. Since 2 pi over b is 0.5, so 2 pi divided by half is 4 pi. Compressing the graph of sine x horizontally towards the y-axis is h of x equals sine of bx, provided that b is greater than 1. Bx is greater than or equal to 0 and less than or equal to 2 pi implies that x is greater than or equal to 0 and less than or equal to 2 pi over b for one cycle. Consider f of x equals sine x here in red, and its transformation h of x equals sine of 2x. The new period is going to be x is greater than or equal to 0 and less than or equal to pi. Since we have 2 pi over b is 2, 2 pi divided by 2 is pi. And you see that any point on this original graph is going to move towards the y-axis. The period of sine bx and cosine bx is given by period equals 2 pi over the absolute value of b. You could also write it like this. The absolute value of b equals 2 pi over period. True or false? The period of sine 2x is 2. Well, b value, here, sine bx, this is sine 2x, therefore b is 2. We have 2 pi over b, which in this case is 2. So the period of sine 2x is pi, not 2. So this one is false. Next, we have the period of 2 cosine 0.25x. Well, b is 0.25, so the period is 2 pi over b, which is 0.25. So that is 8 pi. So this is true. Next one, we have period of 5 cosine pi x. Now, keep in mind, this a value doesn't come into here at all. So it doesn't really matter what number is out front. All we care about is the number that is the coefficient of x inside the parentheses. So here we have period of 5 cosine pi x. So 2 pi divided by b, which is pi. So the period is 2. This is true. Finally, we have the period of cosine of pi x over 12 is 24. Therefore, if we write this like this, pi over 12x, b is pi over 12. So if we take 2 pi and divide it by b, that's pi over 12. Another way to write this is 2 pi times, and then you flip the fraction, 12 over pi. Pi's cancel, 2 times 12 is 24, so that is true. And there you go, false, true, true, true. Let f of x equal 3 plus sine x for each function below. First, we're going to write a rule for the new function after the given transformation, determine whether it's a horizontal compression or stretch, and what's the new period. All right, so here, this is going to be 3 plus sine of 2x. Because b, this value here, is greater than 1, this is a compression. And the new period is 2 pi divided by b, so the new period is pi. Here we have 3 plus sine of 6x, and b is once again greater than 1, so this is a compression. And the new period is going to be 2 pi divided by b, which is 6, so pi over 3 is the new period. Here we have 3 plus sine of 1/3 x, so b is between 0 and 1. So this is a stretching, and the new period is 2 pi divided by b, which is 1/3, or you could also say that's 2 pi times 3 over 1, so 6 pi. And there are the answers. Let f of x equal 2 sine x. Its graph is displayed below. The function g is given by g of x equals f of 0.5x. Carefully sketch the graph of g of x on the grid. Write a formula for g that does not involve f. All right, so the equation for g is going to be 2 times sine of 0.5x. And the transformation between this graph and our new graph is just this number right there, that b value between 0 and 1, which means we're stretching away from the y-axis by a factor of 0.5. So we're going to take this point and then double the x value. So pi over 2, we double it, and this point is going to move there to pi. Here we have a 0 at pi, so we're going to double it. This 0 is going to move there. Here we have 3 pi over 2, so we're going to double that, and it's going to move 3 boxes away that way. Now this 0 at 2 pi is going to move over to 4 pi. What this looks like is this. And there is our graph.